Jai Hind everyone, my name is Mukulit Goel and I am assistant professor in Department of MCA. Today I am going to present a lecture on Cocomo and Cocomo 2, which is the part of the subject software project management, and have the subject code KCA 013 and it is useful for MCA students. So I will start with the content of my slide. So first I will discuss about Cocomo model, then types of Cocomo model, and then I will discuss Cocomo 2. So first of all, the full form of Cocomo is cost constructive model. It is proposed by B.W. Boehm. This model is proposed by B.W. Boehm, in which he differentiate or describe three project into three type of project. One is basic, another one is intermediate, and third is detailed. So and applied Cocomo in the three forms, which is organic mode, semi-detached mode, and embedded mode. Now I will describe what is the difference between all these type of projects. So first of all, what is organic mode? So in organic mode, it defines that the project size should be between 2 to 50 kilo lines of code, means the project should be in small size, have some experienced developer which have the familiar environment, and it have the little scope for innovation, and deadlines are not tight. Okay, and it is the use of this project or for the development environment it requires is in-house. So second mode is semi-detached mode, which describes that the project size should be between 50 to 300 kilo lines of codes, means it describes about the medium size project in which there is a team requirement which is of medium size, and there is an average experience required for the completion of this project. In this type of projects, there comes other database systems, compilers, and editors. Its innovation is medium, and its environment also requires might be in-house or might be in any company. Third is embedded type of mode, in which we describe a large project which solve the real time system problems and the complex problems, and the line of code requires in this type of mode is more than 300 kilo lines of code. And the examples of embedded systems are like ATM, like air traffic control. All these are the examples of embedded system in which the innovation is significant and the deadlines and is also a very tight. So in Cocomo model, in cost constructive model, we describe all these three types of modes, and it is the part of the software project planning, in which there are three type of model which I described earlier. First is basic, another is intermediate, and third is detailed. So first I will talk about the basic model. Basic model describes the form, takes the form E, which is described as the effort in person month. KLOC is the line of code required for any project. D is the development time, and A, B, C and D are the coefficients, and these coefficients have the constant value as given in the table. Means for A the organic mode have the value of A as 2.4, B has the value of 1.05, C has the value of 3.25. For semi-detached, A has the value of 3.0, B has the value 1.12, and C has the constant value 2.5. For embedded project, A is 3.6, B is 1.2, and C is 2.5. So the use of this formula or this form and the values of these coefficients are that for finding the requirement, of any project, means that project uses 100 line of code in which only 10 employees are company has only 10 staff, then how much time, how much development time it will take, how much effort it requires. So and how much productivity will be, what is the productivity level for that project, it is calculated by using these values, using this form. So for basic model, effort E is equal to A into K LOC raised to the power B, and D is equal to C value of effort raised to the power D. So with this we we will solve it using a numerical. So after solving, I will take the example of a numerical. So we suppose the project was estimated to be 400 kilo line of code, and we have to calculate the effort and development time for each of the three modes: organic, semi detached and embedded. So for finding the effort, we use the formula E is equal to A into kilo line of code raised to the power B, and development time is equal to C kilo line of code raised to the power D. So for organic mode, we have seen that the value of A is 2.4. So we put all these values in this formula E. So the effort we find out is E 2.5 into line of code, which is 400 raised to the power 1.05. After calculation, it will comes 1295.31 person months. For development time, D is equal to 2.5 into E raised to the power 0.38. So it will comes 38.07 person months. So for semi detached mode, effort is equal to 3.0 into 400 raised to the power 1.12, which comes 2462.79, means 2462 person months, and the development time is 38 person months. For embedded system, so the E is equal to effort is equal to 3.6, 400 raised to the power 1.20 is equal to 4772.81 person months, and development time is equal to 2.5 into 4772.8 raised to the power 0.32 is equal to 38 person months. So okay, so with this we have find out ki what are the effort and the development required for developing a project if the project is estimated to have 400 kilo lines of code. So let's take another example in which we also find the average staff size. So the project size is of 200 kilo lines of code is to be developed, and the software development has the average experience of similar type of project. So calculate the effort, development time, staff size and productivity of the project. So when we talk about the similar type of projects, so for similar type of project, what we take the semi detached mode. So we take the values from the semi detached mode. So effort is equal to 3.0 200 raised to the power 1.12, and development time is equal to 2.5 into effort raised to the power 0.35. So for effort is equal to 1133.12 per person months, and the development time is equal to 29.3 person months. So average staff size required is E divided by D, which is 1133.12 divided by 29.3, which comes 38.67%. Approx 39% are required as an staff size. So what is the productivity? So the productivity is KLOC divided by effort. So KLOC is 200 and the effort is 1133.12, which comes 0.1765 kilo lines of code per person month. So it comes 176 line of code per person month. So now we next come to the intermediate model. In intermediate model, there are the 4 drivers. One is cost driver. So in cost drivers, there are 4 types of attributes. One is product attributes, second is hardware attributes, third is personal attributes, and fourth is project attributes. So on the basis of these attributes, we define the values of for each attribute which is described in this table, and the based on the rating, it is divided into 6 parameters, which is very low, low, nominal, high, very high and extra high. So when we talk about these attributes, first is product attribute, in which the first attribute is required software reliability. The second attribute is size of application database. The third attribute is complexity of the project. So these three attributes comes under the product attributes. Now the second attribute is hardware attribute, in which there comes a runtime performance constraints, memory constraints, virtual machine volatility and turnaround time. Next is personal attributes, which consist of analyst capability, programmer capability, application experience, virtual machine experience and programming language experience. Fourth is project attributes, which has modern programming practice, use of software tools and the required development schedule. So on the base of these around 15 attributes, each attributes have some defined values. So for product attributes, we have the reliability, data and complexity. So reliability, size and complexity. So when reliability is 0.75 is considered as very low and 1.0 is considered as the very high. So for all these attributes, we have a defined value, and all these defined values for all these attributes is used for finding the value of effort and development time. So for organic, semi-detached and embedded mode, the A, B, C and D as the remain the constant, but their values are different from what we have seen in the basic model. So for organic mode, the value of A is 3.12, the value of B is 1.05, the value of C is 2.5 and the value of D is 0.38. For semi-detached, the value of A is 3, B is 1.12, C is 2.5, D is 0.35. For embedded, the value of A is 2.8, the value of B is 1.2, the value of C constant is 2.5 and the value of D constant is 0.32. So all these are the value of the coefficient, and with these coefficient we will find out the effort and development time as per the questions given. Now last I will come for the detailed Cocomo model. In detailed Cocomo model, there are the phase sensitive efforts and the 3-level product hierarchy. So in phase development efforts, there are the cost drivers, which basically decide the design and testing, and manpower allocation for each phase. And the 3-level product hierarchy consists of modules, subsystems and the system level modules. So when we talk about the development phase, we have some plan requirements and efforts and development time. So effort should be 6 to 8% and development time is 10 to 40%. So the percent depends on the mode of the size, means how many lines of code is required for developing a project, and the mode which is organic, semi-detached and intermediate. So the design effort should be 16 to 18%, the time required is 19 to 38%. For programming, the effort should be 48 to 68% and the time required is 24 to 64%. For integration and testing, effort required is 16 to 34% and time required is 18% to 34%. So all these phases describe the percent of effort time required for doing a planning for development of any software project. So the distribution of life cycle, software life cycle, what we are doing is, for requirement and product design, we need a plan and the system design. In detailed design, we create a design of the project. For code and unit test, we code the module and test the individual modules. For integrate and testing, we integrate each module which we have coded and we developed, and then test the project as a whole system. So I would take an example, a new project with estimated 400 kilo line of code, embedded system has to be developed. project manager has a choice of hiring from the two pools of developer which are highly capable with little experience in the programming language being used, or the developer of low quality but a lot of experience with the programming language. So what is the impact of hiring all developers from one or the another pool? So this is the case of the embedded system, and we have the line of code is 400. So we have find out the effort required. From the effort required, we have find out the effort and development time when the developers are very highly capable and have very little experience in the programming. All these values come from that the table. So 2.5 into 3470 is raised to the power 0.32, come to 33.9 person months, and the effort required is 3712 into 0.9348, which comes to 3470 person month. So in case 2, when their developers are of low quality and but lot of experience, so their E is equal to 4528 person months and the development time is 36.9 person months. So with this, in both the cases we can find out that case 2 requires more development time and more effort rather than case 1. So what we say that the case 2 requires more effort and time, hence low quality developers with lot of programming language could not match the performance of very high capable developers with a little experience. Now I come to the Cocomo second. It is the advanced version of Cocomo, in which the following the project is divided into the following categories. One is the end user programming, application generators and compositions, application compositions, system integration and infrastructure. So the project or application are identified by these 5 categories. So first we talk about the stage 1, when the model name is application composition estimation model. What we'll do, we do the application composition, and its application is to addition. This model is used for the prototyping stage of application and infrastructure and system integration. Stage 2 is early design estimation model, in which application generators and system integration is used and is used in early design stage of the project when less is known about the project. Stage 3 is post architectural estimation model, in which used after the completion of the detailed architecture of the project. There comes the application composition estimation model, flowchart and steps involved in this composition model. First we access the object counts, then we classify the complexity level for each object, assign the complexity weight to each object, then determine the object points, compute new object points, calculate the productivity rate, and then compute the effort or estimate the effort in person month. So for this, what we need to require to specify more, we need to specify more on the complexity level of each project, because on the basis of this complexity we assign the weights for each object, and after assigning those weights we determine the object point and compute them. After computing this, we find the productivity rate and compute the estimation effort. So in Cocomo 2, the project is not divided into 3 type of mode, but it is divided onto the stages which is required based on the application up to the total completion of the architecture. Thank you very much. With this I will end my lecture.